I think it's been actually a progression. I first became very interested in chemistry in high school and undergraduate, mainly because it really allowed me to develop things with my hands. Chemistry is a very hands-on science. After that, I realized that I really wanted my chemistry to do something, and that naturally led to material science, since there you always make things and synthesize materials, but always with a purpose, with an application in mind. So our core competency in the group is polymer synthesis, where we develop fundamental techniques to make new functional materials. And our objective there is to develop new building blocks that we can put together in different ways to make and introduce new functionality. And one of the core things that we do in the group is to use these new synthesis techniques to make materials with specific applications. And there are three main application areas in the group. The first is in energy materials, where we develop new photovoltaic systems and battery materials. Our second area is in biomedical systems. In that case, we develop nanoparticles primarily as diagnostic and treatment agents for cardiovascular disease. And our third area is microelectronics. We've developed an area called block polymer lithography, where we try and make the features on chips smaller and more diverse in structure. And so they're the major areas that we're working on in the group. I think there are three main areas that we're going to see key breakthroughs in both the near-term and also long-term future. That is energy, environmental, and also medical. And I believe strongly that polymer chemistry and material science can play a major role in all three of those areas. In terms of energy, we need cleaner, cheaper sources of energy, not only in the developed world, but also in the developing world. And again, material science can play major roles, especially in the area of photovoltaics, new battery systems in those specific areas. In terms of environmental, growing up in Australia, I realize the need for access to water. There is major parts of the world which don't have access to enough water, and so we have to develop techniques not only to use water more efficiently, but also have access to water, for example, derived from seawater. And again, we see the key area of materials chemistry come into play there. Reverse osmosis is one way of obtaining clean drinking water from seawater. However, it is energy intensive at the present point in time, and so there's a real need to develop new approaches to clean water. And finally, in the medicine area, we need to target diseases. And again, by developing nanoparticles that have targeting peptides on the surface that will deliver diagnostic and therapeutic agents, we can really make breakthroughs and not only cure disease, but also allow us to really understand and diagnose the disease at a much earlier stage. Being a synthetic chemistry group, our group uses a wide range of instruments, not only to synthesize materials, but also to characterize them. My favorite piece of instrument is always the one I've just bought. And so we just recently bought a very large, very well-equipped glove box, which allows us to do inert chemistry. And it's actually being very critical for our battery efforts. We need to work in an oxygen-free, moisture-free environment. And so this is one piece of equipment that has really enabled a lot of our research in the battery area. In terms of major pieces of equipment or trends in the future, being able to characterize things on the nanometer, even the atomistic size scale, is absolutely critical. And that's an area that we're devoting a lot of resources to, and is absolutely critical as we try and characterize our materials on a much smaller size scale. One of the things that's always interested me from being very, very young is civil engineering. I actually like and very much am intrigued by the concept of making and designing major infrastructure, such as buildings, dams, ports. And one of the things that really I find quite interesting is that you see the outside facade, but there's so many things that are buried inside that you never find out about, but is fundamentally important to the functioning of the structure. And so that's what I find actually quite interesting, and you can actually draw parallels with polymer chemistry and material science. Again, you're designing things that on the nanoscale level may have a totally different structure than you would expect based on their physical properties and what you actually use them for. So civil engineering I find actually a very fascinating field. Science and engineering is one of the biggest hopes for developing countries. As they make transitions from developing country to developed country and have rising populations, there's a greater need for new material science activities and discoveries. And I'll just give you a couple of examples. One that we were talking about before was the environment, a continual need for clean drinking water as the population increases. And this is again an area where material science can come to the fore. In actual fact, we have a new ventures competition for undergraduates and graduate students at UCSB that really does focus on developing new breakthroughs in material science. And one of the things that has come out of that in recent years is a number of efforts to develop clean filters that allow you to filter contaminated well water or other contaminated sources of water, and very cheaply and very efficiently obtain clean drinking water. Another area is obviously energy. A developing country needs energy, but it would be nice for them to bypass all of the legacy issues that developed countries have had, and that's pollution. And so if we can deliver to them solutions that allow them to generate energy cleanly without having to build coal-fired power plants, that would be a huge benefit, not only for them, but also for the rest of the world. The simple answer to that is no. There is a continual need for improvement. We need to make things faster. We need to make things smaller, stronger, etc. And material science plays a key role in all of those areas. And if we look from a historical viewpoint, we see a continuing evolution of materials properties and material science. If we go back thousands and thousands of years, ceramics have been around for a long, long time. Yet nowadays, ceramics is a very interesting area, very hot area. People are looking at all different types of ceramics. The tiles on the space shuttle were a very advanced form of ceramics. You can also get nowadays things called zero gels and aerogels, which are extremely lightweight ceramics that have a lot of interesting applications. One of the big areas of ceramics that is emerging is in photovoltaics. People are looking at these materials as new type of semiconductors. So there we have a field that is thousands of years old, but is responding to the developing challenges that we have as a society today. And so my answer is a definitive no. There are always interesting things to research in material science because there's a need for new materials every day. My advice is very simple. Research in these areas is an enormous amount of fun. I very much like polymer chemistry and material science because it allows you to combine fundamental aspects which are scientifically very challenging with real-world applications. And so you can actually tell people on the street, why am I interested in this research? Why am I doing it? And that, to me, is extremely satisfying. The other thing I very much like about doing research is that it cuts down a lot of barriers. And so you can travel the world, you can meet interesting people, discuss science, discuss engineering, without really having to worry about political issues. And so it really is a common theme that everyone in the world speaks. And so it really is a lot of fun. I've had a wonderful time over my career doing research in these areas, and I look forward to it continuing in the future.